to do today was, rather than do anything new, let's just review all the stuff that we talked about before break. So I've got this worksheet basically split into two parts. So we've got doing some operations with complex numbers, and then doing some of the equation stuff, solving stuff that we did last time. And then the last half of it is literally doing the same stuff with just a different problem. So let's work through the first 10 here together, and then I'll give you the last 10 for review. And then Wednesday and Friday we'll talk about the last new section that we have. Monday we'll review for Wednesday's exam, and then talk about the final on Friday. So your final exam is scheduled for Wednesday of finals week, which is the 18th. And I believe it's at noon, if I remember correctly. I'll double check the time, but I'm pretty sure that's right. I'll have to double check, but I think that's right. All right. In any event, let's just go through these first few problems. Make sure we all remember what we need to do on these. Make sure we're all on the same page. And like I said, I'll leave the last one for you to work on for practice and holler at me as we go through. So remember when we're doing radicals, and I want to simplify radicals where we have a negative under the radical to start. What do we want to take care of first? What do we want to do? Make it an I, right? So take care of the negative under the radical first, make it an I. So make this I times square root of 245. I'm going to turn off this. It was super cold here earlier. It's so loud I feel like I'm competing with it. All right. Well, the sound is much better. All right, so now let's simplify 245. Let's factor that. Let's see. 5 and 49 looks like. And then 49 is 7 and 7. So how does that square root of 245 simplify then? Bless you. Square root of 5. Good, exactly. So since we have a pair of 7s, we get a 7, we simplify that part, and then the 5 is still 5. That look familiar? Awesome. All right, so when we do the next couple, same idea. Let's make the radicals into i's first. Terms involving i's, and then go ahead and do the operation. What does square root of negative 64 end up simplifying to? Okay, the I square root of 64. And then the same thing for the square root of the 121. And what is square root of 64? That one's 8, good. And square root of 121 is 11. Good. So now we're doing 5 plus 8i and plus negative 3 plus 11i. What do we get when we simplify that? Good. So yeah, the 5 plus the negative 3 will give us 2. 8i plus 11i will give us the 19i. Okay. Do the exact same thing for the next one. We're just subtracting instead of adding, correct? Okay. So if we do that square root of negative 16, what do you get when you simplify that part? I squared of 16 and square root of 16 is equal to 4. Good. So we get 4i. And if we do the square root of negative 100, that simplifies down to 10i. Good. Everybody okay with getting those simplified? And now we just need to subtract, making sure we distribute our minus to both pieces, right? 8 minus 12 gives you negative 4. And then we have negative 4i minus a minus 10i. There we go. It'd be a plus 6i. Good. Because a minus will make a plus, right? So we get negative 4i plus 10i. So we get positive. Is that okay? All right, let's do some multiplication and division. Multiplying, same kind of concept. We just have one extra little step to do. So let's simplify first this negative radicals there. Square root of negative 4 is the same thing as I square root of 4, and square root of 4 is 2. So we get 2i, good. 5i, good. So we get 1 plus 2i times negative 7 plus 5i. Then what do we do? You multiply it all out, so what do you get when you multiply? Ooh, careful. I agree, it's I squared. What's 2 times 5? 2 times 5 is 10, right? Okay, good. Cool. Yeah, we got to multiply, all right? So we multiply them out just like what we did with polynomials, right? 1 times negative 7, 1 times 5i. 2i times negative 7, 2i times 5i. So we get negative 7 plus 5i minus 14i plus 10i squared. We okay with the distribution there? And then remember now, what do we always replace I squared with? Negative 1, right? So plus 5i minus 14i makes a negative 9i, and then we got minus 10 on the end, right? Remember your I squared is always negative 1, right? So we have plus 10i squared to start with, becomes a negative 10i. Excuse me, not negative 10i, just negative 10. And then simplify, we'll get negative 17 minus 9i. That one okay with everybody? Remember the I squared was that little extra step that we had to do above and beyond what we did with polynomials, right? Replacing the I squared with a negative 1. Otherwise, it's just like what we did with polynomials. Let's look at this number 5 here. Remember when we want to divide, what do we have to do? We want to divide by a complex number, what do we have to do? Good. So yeah, we have to divide, we do the conjugate, right? We change the minus to a plus and multiply top and bottom by the conjugate. And now we just distribute on the top and distribute on the bottom. When you simplify the entire bottom, what has to happen? What goes away? So in particular, no more i's are on the bottom, right? When we simplify on the bottom, the I has to go away. That's the whole point, isn't it? Okay, what do you get when you distribute the top? When we multiply out the top, what do we get? Yeah, it's negative 30, okay. Minus 5i, isn't it? Yeah, okay. Good. Everybody okay with that part? What do you get when you multiply out the bottom? Yep. Okay, so yeah, so notice in the middle terms you'll have a plus 6i and a minus 6i. Those will go away. And then minus I times plus I gives a minus I squared. Minus 5i plus 12i on top there gives you a plus 7i. What does the 2i squared become? You got a plus 2i squared. What does that become? Negative 2. Good. On bottom, the plus 6i and the minus 6i cancel each other out, which has to happen. If you're doing this right, that always happens. Minus I squared becomes what? So the I squared is negative 1. We got a minus, so it's going to be plus 1. Okay, good. On bottom, when you do this for division, on the bottom, when you simplify this stuff, you should be adding two numbers together every time. There should never be a subtraction down here, and there should never be an I down here. There should always be adding two things together every single time. And now we're almost done. When we simplify that top, we get negative 32 plus 7i all over 37. That one look familiar? A little bit more work involved on that one, but not too bad. Division's the most complicated of the ones we have to do for arithmetic. Okay, let's look at the next one where it asks us to compute I to the 936th power. Phew, that was a big one. What do we have to do to compute that one? What do we do? Divide the exponent by 4. Good. Take your 936 and divide it by 4. Say again? It's a whole number. Good. So 936 divided by 4 should give you what? Say again? 234. And there's no remainder, right? It's a whole number. You don't get any decimal part at all. Right? So that means that your I to the 936th power is the same thing as I to the 0 power. It's the same as the remainder. Anything to the 0 power is always what? No matter what number you take to the 0 power, you always get 1. Good. So I to the 0 is 1. I actually lied a little bit. There's one number when you take it to the 0 power, you don't get 1, and that's 0 to the 0. That one's undefined. That's a discussion for a different day. As far as you're concerned, anything to the 0 power is 1. Yep. So, yeah, remember your possible remainders. Obviously, if you get a whole number, your remainder is 0, right? If you get a 0.25, that's a remainder of 1. If you get a 0.5, that's a remainder of 2. And if you get a 0.75, that's a remainder of 3. Say it again. Well, I mean, if it's just a whole number, then it is a remainder 0. You can. I'm just writing down what the r's, the remainders are. Okay. So And then just remember that your I to the 0 is 1, I to the first is I squared is -1, and I cubed is -I. Because you replace it with remainders. Yeah. Is okay? Okay. All right. The next couple here have us doing what we refer to as square root method for solving. So if we want to get x by itself in number 7 here, we want to take the square root of both sides. But remember, when you take the square root of both sides of an equation, what do you always get? What goes out in front of your square root sign always? Plus or minus, right? Yep. Always get a plus or minus. And then we simplify the radical like we always do. Since we have a negative under the radical, we make it an I. So then we get I times square root of 112. We break down our 112. I factored it all the way down. Notice in this case we get 2 pairs of 2's at the very, very end. So how can we rewrite the square root of 112 then? Good. Exactly right. 4i root 7. That's exactly right. That okay? So number 8 also uses our square root method. But I need to do something to both sides of the equation before we try to take the square root. What do we need to do first before we do the square root? We're going to divide the -4 over, right? We got to get that x minus 3 squared all by itself. So divide both sides by -4 and get x minus 3, the whole thing squared, equals -12. Now that we have the squared by itself, we do the exact same thing that we did in the previous problem. We get rid of the square by taking the square root. And then same idea, when you take the square root of both sides, you always get plus or minus. And then simplify your radical. We have the negative under the radical, pull the I out. Break down our 12. So after we've got our 12 broken down, how can we rewrite square root of 12? Good. A 2 comes out in front. We're left with a root 3 underneath. And then finally, the last thing we need to do is what? To solve for x. What do we need to do? Yeah, bring the 3 to the other side. Good. So add your 3 to both sides, and we get x equals 3 plus or minus 2i root 3. What questions do you have on that one? That one okay? finally, the last two involve our quadratic formula. So let's write that off to the side. What is quadratic formula again? X equals what?
Plus minus
Yeah, you're right.
b squared minus 4 times a times c.
Good. And then,
Over 2 times a.
good. Yep, that's exactly right. Yay! Woo! Exactly right. So yeah, opposite b plus or minus square root of b squared minus 4ac. And then don't forget, it's all over, right? The 2a is below the b and the square root piece. All over 2a. Good. So in this equation over here, what's a equal to? 1, because that's the coefficient on the x squared. B is 6, and good. C is 34. So plugging all this stuff in. So we get minus 6 plus or minus square root of 6 squared minus 4 times 1 times 34 all over 2 times 1. Six squared is 36. 4 times 34 is 136. So we get 36 minus square root of 136 under the radical. So we get negative 6 plus or minus square root of 100 all over 2. How can we simplify square root of 100? It's 10i, good. Notice that you can factor a 2 out of both terms in the numerator. And then what can you do with the 2's now on top and bottom? Cancel them out. Good. And so we end up with finally negative 3 plus or minus 5i. Yep. Yeah, if you divide it, you have to divide both pieces of the top. That's right. Yep. You could do it, think of it that way too. That one okay? All right, let's do this last one together here, and then I'll turn you loose on the end of them. Okay? What's that? I can turn the heat back on too. Oh, I don't have to yell over the heat though then. All right. So notice that our B in this case is negative 6, right? So when we do the negative of B, we'll get a positive 6 plus or minus square root of negative 6 squared minus 4 times 1 times 4 all over 2 times 1. Negative 6 squared is 36. 4 times 4 is 16. So we get square root of 36 minus 16 on top. So we get 6 plus or minus square root of 20. If you break down 20, that's 2 times 2 times 5. So you get a 2 root 5. And then you can factor out a 2 and cancel that as well. So you get 3 plus or minus root 5. So it's the negative of negative 6. So it says your b here is a minus 6, right? When you do the opposite of minus 6, you get positive 6. It's always, whatever the b is, they're going to flip the sign on it in that first one. So notice that the first problem we did was positive 6, so it made it negative 6. The second problem was negative 6, so it made it positive 6. Yeah. Yeah. Mm-hmm. Yeah, that's fine. Yep, you can do that. Yep, absolutely. That's okay. All right, so go ahead and work on the other. The next problems are just like the ones we just did for examples. Okay, work on those. Holler if you've got questions, or if you think you're good to go.